Welcome friends. Today we will learn about IP version 4 addressing scheme. IP address is a identifier used in the IP layer in the TCP IP protocol suite, which is used to identify the connection of each device within the internet. This IP version 4 address is a 32-bit address that uniquely and universally defines the connection of the host or a router to the internet. The IP address is the address of the connection. It is not the host or the router, which means if you are going to move the corresponding device, that is host or router, the IP address will be changed. One thing we need to remember is that to identify a particular host within a particular internet, two addresses are basically used. One is logical address and another one is physical address. This logical address we call it as IP address, which is 32 bits, and this physical address is associated uniquely with respect to each and every host or a node with respect to the NIC card, that is network interface card, which is available in every node, every system. That we call it as physical address, which is of 48 bits. So with these two addresses only, a node is identified uniquely with respect to the corresponding internet. Now, to understand in detail about the IP version 4 addressing, we need to understand the basic terminologies. First one is address space. The address space is a total number of addresses used by a particular protocol. So if a protocol uses B bits to define an address, the address space is 2 power B. Why 2 power B is, we are going to use a binary notation. So in binary we know that either 0 or 1 is possible. So there are 2 power B combinations or possibilities available. Since our IP version 4 addresses uses 32-bit address, okay, so which means the total address space we have is 2 power 32, which comes around 4 billion. So 4 billion addresses are possible in IP4 address scheme. Now, what is a notation or representation used for specifying this IP4 address? Actually, 3 notations are used for specifying IP address 4 addresses. One is called as binary notation base 2, and the second one we call it as dotted decimal notation, and third we call it as hexadecimal notation. So this pictorial representation gives these 3 notations in detail. In binary, the 32 bits are represented in octets, that is 88 bits, separation of 88 bits. Decimal, these 8 bits is converted into equivalent decimal. This 8 bit is converted to equivalent decimal, and similarly these two. So put together we are having 4 values separated by decimal point. And in hexadecimal, the 4 bits of each binary values, that is in each octets, each 4 bits forms the equivalent hexadecimal value to give this representation. So 3 representations are used. Now, what is a hierarchy in addressing? A 32-bit IP version 4 address is hierarchical in nature. So it is divided into 2 parts. The 32-bit address is divided into 2 parts. One is called as network part. That network part we call it as a prefix. And the second part we call it as suffix, which is going to exactly define the node or going to represent the node. So the first part prefix, it is going to define the network or represent the network, and the second part is the suffix, we call it as, which represents the node. A prefix can have fixed or variable length. It can be fixed or variable length. Actually, the IP version 4 addresses uses a fixed prefix length. Since it uses a fixed prefix length, we call it as classful addressing scheme. There is another scheme called as classless, in which the prefix length is variable, that we will learn in detail in the next video. Now coming back to the pictorial representation of this hierarchy in addressing. So the IP address is divided into totally available 32 bits. These small n bits we call it as a prefix, and remaining 32 minus n bits denotes the suffix. So this prefix is going to define the network part, that is a particular node in the internet in which particular network it is going to reside. That determines this prefix. The second one, suffix, is going to identify the exact node within the network. Now we will learn about what is this classful addressing scheme is. Initially, when the internet was started, an IP version 4 address was designed with a fixed length prefix. But to accommodate both small and large networks, what they have done is they have fixed the corresponding prefix length to 8, 16 and 24. Based on this fixed scheme, they have classified or categorized the IP addresses into 5 classes. That IP version 4 addresses into 5 classes, namely A, B, C, D and E. So this we call it as classful addressing. Now we will go in detail for identifying which particular IP address falls in which class, how to identify that. So in class A, the corresponding the network length is 8 bits. As I have told already, the IP version 4 address is two parts. One is network part and another one is node part. So the network part in class A is 8 bits. So out of 32 bits we have assigned network 8 bits. Remaining 24 bits is for identifying the node. So because it is a classful addressing, each and every node part, that is network part, it is going to be identified with a prefix. So in class A, the prefix is 0, that is most significant digit will be 0, so which defines that it is a class A address. So here it is remaining 7 bits are there. So there are 7 bits we will be using for the network identifier. So totally how much network is possible in class A network is 2 power 7, which is equal to 128 networks. Remember that even though there are 8 bits in the corresponding part, that is network part, the first bit, that is MSD, most significant digit, is used for identifying the network, which is 0. So the remaining 7 bits are used for forming the network. So that is 2 power 7 is equal to 128. Next, class B address. Similar to that class A, class B addresses is divided into network part as 16 bits and host part as 16 bits. So 32 bits are divided into 2 equal halves. So how to identify with respect to the class B address? The prefix is 10 in class B. So the first 2 MSD digits are 10. If it is 10, then we can say it as class B address. And the remaining 14 bits is used for network identifier. So totally how many networks are possible in class B address is 2 power 14, which is 16,384. Class C addresses, the prefix is 110. So prefix is 110. Actually the total network bits assigned for class C address is network length is 24 bits. Only 8 bits is used for host or node. So in that 24 bits, the first 3 MSD bits are 110. So the remaining 21 bits will be used for network identifier. So 2 power 21 is equal to 2,97,152 networks are possible around the world in class C address. Now this class D is not divided into prefix and suffix. Both class D and class E addresses are not divided into prefix or suffix. The class D address prefix will start with 1110 and it is used as a multicast address, and class E addresses starts with 1111. It is used for research purpose, not for normal addressing purpose. So this pictorial representation shows the corresponding class A, B, C, D addressing schemes in IP version 4. So as I told, the total address space is 4 billion, 32 bits, 2 power 32. In this class A, So the first 8 bits, these 8 bits is going to be the identifying the network. In that the first MSD is 0. The remaining 7 bits are used for network part. So we are having the decimal, that is the range of network is from 0 to 127. So you need to convert this decimal value, that is binary value, to decimal. Okay, so all 8 bits are 0, that is all 7 bits are 0 after the prefix. So it is 0 0 0 0, 7 zeros, and totally how many, all bits are ones, 7 bits of ones, so which is equal to 127. So totally 0 to 127 networks are possible. Similarly, 10 is a prefix for class B. 16 bits are network, 16 bits are node, identifying host. Similarly, class C addresses 110, 24 bits here for network, only 8 bits are assigned for host. Class D 1110 is a corresponding prefix length, and class E 1111. Class D is used for multicast addresses, and class E is reserved for future use. Now, when the internet was initially started, rapidly many organizations requested the address, and this address distribution was not properly. So the addresses was vanished. So many organizations requested, and this distribution was improper. So now when the new organization requires any IP address, it was not available. So this we call it as address depletion. So no more addresses available for organization. So we need to go for avoiding this address depletion problem. There are 2 temporary solutions proposed and 1 permanent solution. That is, one permanent solution is the IP version 6, which is now developing, or it is in implementation stage. Now with respect to the 2 temporary solution, one is called as subnetting and another one is called as supernetting, which we will learn in detail in the next video. Now before that, what is the advantage of this classful addressing? So because the hierarchy is fixed, we can easily identify the particular what class the corresponding IP address is, because it is hierarchical in nature, and because the prefix length is also fixed, we can find the prefix length immediately and with no extra information needed. So this is a major advantage of classful addressing. Now to overcome the address depletion problem, as I told, 2 temporary solutions are subnetting and supernetting. In subnetting, class A and class B addresses are divided into blocks, and while dividing, the prefix length is variable. So as on goes, the organization has got several subnets, that is group, that is a particular block of addresses is used for a organization, but the entire block may not be used. So some of the block which is not used, it is again divided into several blocks, that is again the subnetting is performed and it is given to the smaller organization. So the larger organization is not happy about the dividing this block and giving some of the blocks to unused addresses to the smaller organization. So there is a practical implications in it. So subnetting is also a temporary solution. So they have gone for supernetting, another temporary solution in which class C addresses are divided into blocks, but only 256 addresses are available in class C block. But one fundamental disadvantage, major difficulty is it makes routing of packets more difficult. So the corresponding 2 temporary solutions, subnetting and supernetting, we will be learning in detail in the next subsequent video. Thank you very much.